underground utility detection and mapping surveys. Utilities. Utility, a privately, publicly, or cooperatively owned line, facility, or system for producing, transmitting, or distributing communications, cable television, power, electricity, light, heat, gas, oil, crude products, water, steam, waste, or any other similar commodity. Utility survey. Definition. Utility survey involves detecting, locating, identifying, and mapping underground utility lines. Other terms used for this type of survey include service tracing, underground utility survey, underground utility mapping, subsurface utility survey, utility detection survey, CAT scan, radar survey or GPR survey, utility survey. Benefits. There are many benefits which come from a well-executed utility survey, including safety, avoid utility damage, minimize project delays, save delay and damage costs, designing and planning knowing the constraints, saving costs with producing as-built records, inaccurate, incomplete, and or out-of-date information on the existence and location of existing subsurface utilities, reduces the owners' and contractors' abilities to make informed decisions regarding the project's impact on existing utilities. Utility survey. What's involved? Detection and mapping of buried utilities involves the combination of several techniques, the results of which are blended down to a single interpreted plot. The techniques used will primarily depend upon the required outcome, site conditions, and the type of pipes or cables being targeted. Utility survey. Sample drawing from congested urban street, electromagnetic locators, EML, backbone of utility surveyor's toolkit, consists of transmitter and receiver, has two primary function modes, active and passive. Within these two modes comes various work methods, direct connection, active, tracer cable, active, sonde, active, clamp, active, induction, active, passive, radio and power modes. If work methods above used in logical order, they will provide a reliable picture of the utilities networks within the search area, except plastic pipes. Depth determination to centerline of utility is possible with all modes except radio. Electromagnetic locators, EML, direct connection mode. Transmitter directly connected into the metallic pipe. Transmitter is earthed via another connection to another metallic that is partially buried. Signals are drawn along the pipe in an effort to reach the earth point. This lights up the pipe in question, and the receiver is used to follow and mark the pipe on ground surface. Electromagnetic locators, EML, tracer cable method. This method of application is virtually the same as described above. However, instead of connecting to a pipe, the transmitter is connected to the end of a conductive cable. Prior to this connection being made, the conductive cable is threaded along an accessible duct or drainage pipe to the required distance. Electromagnetic locators, EML, sonde method. Sonde is an actual transmitter which is attached to the end of a flexible cable and then threaded along a pipe. Periodically, the sonde is left stationary within the pipe or duct and its position located and marked on the ground surface using a receiver. The sonde is then pushed further along the pipe and again located and marked from the surface. The result is a series of marks along the ground that can be joined to represent the position of the pipe being traced. Electromagnetic locators, EML, clamp method. Essentially, a clamp is placed around a visible cable and connected into the transmitter unit. The clamp allows the transmitter to induce a signal into the cable through its protective outer casing and results in the receiver being able to actively trace the cable's position from the surface of the ground. Electromagnetic locators, EML, induction. Transmitter is placed on strategic locations around the search site to emit signals directly down into the ground. Signals will travel along the nearest conductors, which will normally be metallic pipes or cables. Receiver is used to circle the transmitter to locate metallic utilities passing through the search area. Handy when direct connection trace has faded due to a break or weakness in the conductor, such as a joint. Electromagnetic locators, EML, passive mode. Employed last, no transmitter used. Has two modes, power and radio. In power mode, receiver can detect live electric cables. Survey is done in grid format. Radio mode allows the receiver to pick up very low frequency radio signals radiated from conductors in the ground, such as metallic pipe or cables. Length of metallic conductor needs to be at least 10 m long. Ground penetrating radar, GPR, introduction. Established technology has recently become widely accepted within the utility surveying market. Not as conclusive as EML systems presented previously. Used in conjunction with EML technology to realize accurate picture of subsurface environment, ground penetrating radar, GPR, introduction. Can work in areas with high background noise, such as electric substations, detect virtually anything that contrasts to the surrounding underground, goes beyond the normal range of EML using lower frequency antennas. Typical depth determination accuracy plus 10% of depth. Ground penetrating radar, GPR, scan. Ground penetrating radar, GPR, interpretations. 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 Ground penetrating radar, GPR, drawbacks and limitations. Cannot identify utility type subject to operator interpretations. Contrast between target and surrounding ground. Small PVC pipe in dry sand can be very hard to see because they both have very low dielectric properties. Highly conductive soils, wet salty clay, destroy signal, render GPR useless. Ground obstructions, topography, ground penetrating radar, GPR, systems. Single scan line, single frequency systems, single scan line, multiple frequency systems, multi-scan line with either single or multi-frequency systems, high-density single-frequency array systems, high-density arrays, multi-frequency systems, ground penetrating radar, GPR, work methods, on-site data analysis, interpretation, and markout, office analysis, post-processing, and interpretation. Ground penetrating radar, GPR, antennas, underground utility surveys, manhole survey. Involves opening manhole covers and performing certain necessary measurements. May include manholes falling adjacent to the survey area or its immediate vicinity. It allows for better understanding of utility networks. Underground utility surveys, manhole survey, cover position and dimensions, cover material, cover photo, chamber dimensions, cover levels and chamber depth from which invert levels can be determined. Entry, exit pipes, ducts, cables with their depth, size, position, and duty. Schematic drawing of the chamber. Underground utility surveys, confidence rating. A measure of the confidence of the surveyor's interpretation of a specific utility. If the only indication of a buried object is from one old record drawing, then the confidence rating would be low. If the object is not only shown on records, but has also been detected with both EML and GPR with reinstatement scar over it, then the confidence rating will be higher. The highest rating is when object has been confirmed with ground truthing.
Underground utility surveys, confidence rating. 5 categories of confidence ratings which corresponds with the quality levels defined in the AC standard guidelines are shown below. Rating A, highest confidence rating. Horizontal and vertical position of utility confirmed by excavation or from viewing within a manhole or chamber. Rating B, medium-high confidence rating. Utility position detected by 2 or more remote techniques but not excavated. Rating C, medium confidence rating. utility position detected by only one remote technique such as sonding, direct connection, or GPR over number of transects. Rating D, medium-low confidence rating, utility position detected by only one remote technique such as passive or induction EML from ground surface. Rating E, low confidence rating, position of utility is only known from record drawings.
Underground utility surveys inputs from the client. Topographic survey. Existing control points. Records. Access. Known hazards. Restrictions on the use of spray paint. CAD drawing and drawing conventions. Underground utility surveys. Outputs from survey company. Markout survey. Utilities will be marked on site using spray paint. Recorded survey. Full record of the survey results depicted on survey drawings, paper, and digital, as per client's required format. Survey report optional.
Underground utility surveys sample survey drawings. Underground utility surveys sample survey drawings. Underground utility surveys sample survey drawings. Underground utility surveys sample survey drawing.